I think many people start wandering in about 7:30. Could I have the slide clicker, by the way? Anyway, very much appreciate. We're all on time. Whatever happened to the concept of Indian flexible time? What has Toronto done to you all? I think many people start wandering in about 7:30. Could I have the slide clicker, by the way? We can't go very far without that. Anyway, very much appreciate this invitation and very pleased to be back in Toronto. Thank you all for turning up. We need the full screen, please. Okay. South Asia is one of the few parts of the world that very early came up with a set of profound answers to the basic, most important questions that man asked of himself. What are we doing here? Why are we on this earth? What is the nature of this earth? What is the relationship of this earth to the sky, the heavens, the moon, the sun? Now, South Asia was not alone in this. There were other parts of the world that also provided profound answers to these questions. Most obviously and most widely taught in the West, ancient Greece, but also China. And the Chinese version of these answers have become, I think, more widely understood lately, thanks particularly to the popularity of this idea of the Silk Road. Anyone brought up anywhere in North America or Europe will from very early on have been taught about the great thinkers, particularly in mathematics, by the age of, 7 or 8. Most of the people in this room that went to school in this part of the world would have learned about Archimedes, his bath, strategy Eureka. By the age of 10, probably, Pythagoras and his theorem. But very few people that went through a Western education will ever have come across their equivalent figures in South Asia, who are absolutely the equal, and in many ways more important for our contemporary mathematics and science than the ones we were taught at school. To give an example, Aryabhatta, a name familiar to Indians who went through particularly the kind of nationalistic Indian education system in the 1950s and 60s, but completely unknown in the West, completely and utterly off every syllabus. Even PhD students in history of mathematics often don't know his name. Yet Aryabhatta realized by about 500 AD or 400 AD that we live in a heliocentric universe, that the Earth revolves around the sun. He calculated exactly the circumference of the Earth and the distance of the Earth to the Moon and the Sun. 1,000 years before Galileo. His work then was taken forward a century or so later by another great Indian sage, Brahmagupta, again a name that will draw complete blanks on any Western education syllabus. Brahmagupta, meditating on the concept, the very Indian concept of sunya, the void, came up with precise definitions of zero. Now, zero is a concept that in various forms has been around since ancient Babylonian times, but Brahmagupta's contribution was to realize that it wasn't just an absence or a placeholder between positive and negative, it was a number in its own right, with its own properties. And he went on to define those properties. It is, for example, the number you get when you subtract a number from itself. It provides 40 or so rules like that. Now, once you've got zero as a number, you then can have place value, tens, hundreds, thousands,